So motion, the type of motion, there are two types of motion. One is the uniform motion and one was the non-uniform motion, right? So in our everyday life, you see, we seldom find objects moving with a constant speed over long distances, right? So if the speed of an object moving along a straight line, it changes. Its motion is said to be non-uniform motion. Like here, on this long journey, the speed of the motion has been changing here. Getting it there? How can we see that? Because here, in 10 minutes, from pole A to pole B, let's say these are the poles. Okay, now. So from pole this to pole this, it took 10 minutes to cover 25 kilometer, right? While from this pole to this pole, it took 10 minutes to cover 5 kilometer. So here the speed was more. The speed was more, no? While in the second case, the speed slowed down. No? The vehicle must have slowed down, so the speed was lesser. Getting it now? Like
Yes, sir.
more distance are being covered in 10 minutes. Here, only 5 kilometer distance are being covered in 10 minutes. Here, 25 kilometer, right? But in the case of uniform motion, you see, in regular interval of time, same distance is being traveled. For every 5 minutes, 10 kilometers are being added to the journey. Getting it, guys?
Yes, sir.
Yes, sir.
Oh, okay. So what are some of the examples of uniform motion, like motion of a clock or motion of Earth around the sun? It takes 365 and half days, right? Okay. And what are some of the non-uniform motion, like motion of bouncing ball, right? So bouncing ball will sometimes jump to this much height, sometimes to this much height, sometimes to this much height. So here also that length being covered by this bouncing ball is not uniform. Getting it? Okay. Or the vehicle moving in a crowd. As soon as the traffic disperses, the speed of the vehicle increases. As soon as the traffic is more, the speed reduces or the vehicle basically stops. Right?
Yes, sir.
Okay. So how do we represent a uniform speed using a graph that we are going to discuss today? All right now. Okay. So the time and distance are being given here. Okay, I'm aware. I think you guys have already you guys are aware of graph now. What is graph?
Yes, sir.
Okay. So we will try to represent the distance and time using a graph. Also, you guys are aware that in order to calculate speed, the formula required is distance upon time. Speed equals to distance upon time, right? Or if you were to take distance using the same formula, it would be distance equal to speed multiplied time. Or we can also write it as time equals to distance upon speed. Please memorize the three formulas. These
Yes,
are
sir.
very important. All right now. Okay. Now, many times, for example, if you were to travel somewhere, for example, on a holiday, if you were to visit somewhere, then if someone asks you, for example, Vaiga, what was your average speed during the journey from your home to, let's say, it could be anywhere. Okay. So what was your average speed? So in order to find your average speed, you will find the total distance that you journeyed and how much time you took, right? So your
Yes, sir.
speed might not have been same throughout the journey. Sometimes it might have been increasing, sometimes it might have been decreasing. Getting it now? So how total distance, how average speed is calculated? It is simply total distance divided by total time. Getting it? Okay.
Yes, sir.
For example, if the total distance is 100 kilometer and total time taken was, let's say, 2 hours. So your average speed will be, it will be 50 kilometer per hour, isn't it, guys? Right now?
Yes, sir.
Okay, okay. Now coming back to what I was trying to discuss here, how to represent distance and time on a graph. This is your time here and this is your distance here. and how the graph of a uniform speed and how the graph of a non-uniform speed will look like. Let's discuss that. Okay. Okay, you guys can see here. The first diagram is of a uniform motion, while the another one is of a non-uniform motion. Further, let's understand step
Sir,
by
can you
step.
explain like there was again?
Which one? Which part?
This one, sir.
This one.
Yes, sir.
Okay, okay. Look here. Shall I start from here? Speed. Is your doubt related to speed or to the average speed?
Average speed, sir.
Okay, average speed. Look here. For example, now, Sundus, you started journeying from your home. Okay, then you reach, let's say, place A. Okay, you started from your home, you reach place A. Then you covered, let's say, 12 kilometer in 5 minutes, or let's say you took 5 hours. Getting it now? Then from place A to place B, you covered, let's say, 15 kilometer and you took 6 hours, right? So here, what would have been your average speed while traveling from your home to your B? So you would find the distance between your home and the place B here. What was the total distance between your home and you and the point B, place B here?
Sir, it's 11 divided by 27, right?
Total distance I'm asking about. I'm asking about total distance.
I mean 27 divided 27.
It would be 12 plus 15. Getting it, Sundus?
Yes.
That is the total distance. You know, we are talking about speed now. Speed simply means distance upon time, right? If only one value of distance is given like this, 10, hour is 2. So you are simply getting the answer as 5 hour, 5 kilometer per hour. But here multiple distances are given and multiple times are given. More than one distance and time are given here, no? Multiple values are there. So there we talked about the average speed. So it is simply the total distance divided by total time, right? And the time would be 5 plus 6 hours. So it is 27 upon 11. Getting it now? Oh,
You just have to add, sir.
yes,
We just have to add it.
you just have to add it. Okay, now add the total distance, add the total time, and then divide them. Okay, you guys are also getting now Vaiga and Chakrika.
Yes, sir.
Okay,
Yes,
okay.
sir.
By the
If it's okay, right? If the answer is in decimal form, right?
okay, okay. Yeah, it is okay. It is okay. We can write it in decimal also. In decimal, it would be 2.4 something. Right now, 2.4 kilometer
It would be
per
2.4
hour.
kilometer. Yes, sir.
Getting it now? Okay, then. Now, let's continue what I was trying to discuss here about the graphs. How do you plot a graph between time and distance, right? So few things needs to be mentioned. Few things needs to be taken care of while you are drawing a graph between distance and time. So you guys should also pose one question here, like, sir, why are we plotting a graph between distance and time? What will it give us? Why are we doing this? Because the thing is that when you plot a graph between time and distance, now you guys are aware that speed is equals to distance upon time. Now speed equals to distance upon time. So
Yes,
when
sir.
I will be plotting a graph between distance and time, I will be getting the third quantity here. That is, I will be getting the speed here. Okay now. So this
Okay,
is
sir.
straight line, someone asked me that, what is this straight line now? What this represents? This straight line is nothing but it represents the speed, right? Okay now. And if you are getting a straight line, it will be a uniform motion. With examples, we will get to know why uniform motion gives you a straight line. If the body is doing uniform motion, then the graph plotted between time and distance, that gives you a straight line, while if it performs a non-uniform motion, you get a curved line. Okay now. Okay. Right now, things might be hazy. The things might be hazy right now. Right now. But as we discuss how to plot the graph between time and distance, it will become crystal clear. Okay, look here. A graph which represents the distance traveled by an object with respect to time is called a distance time graph. So using a piece of graph, you can represent the distance that has been traveled by the object with respect to its time. Okay. So first thing is that, guys, are you able to connect or not? Huh?
Yes, sir.
Okay, now. Okay, I believe things are not getting overhead. Things are not passing over the head. Okay, look here. First thing is that you will be marking the x-axis and the y-axis and divide them in equal quantities. So this is a graph paper here. Okay, you will mark the x-axis here, y-axis and O. All right. Okay, x-axis, let me highlight here, this here, the horizontal line that will be called as x-axis. Okay, and you will also draw a vertical axis also, vertical line also. This vertical line will be called as y-axis, right? I believe you guys have studied these things in math, right?
Yes, sir. I have
Yes.
studied after, so
Yes,
it's
sir.
like for me.
Hmm. This is x-axis and y-axis. We represent the given quantities, given values on these two axes. In the case of distance and time graph, you will be representing distance on the y-axis. Okay. So notice how we have represented distance using the y-axis. Getting it? Okay. And also the point where the two axes meets, it is called the origin. Right now? Okay. Shall we move ahead then?
Yes, sir.
Okay. So now once you have drawn the x-axis and y-axis, now comes the now you need to take the scale. Proper scale has to be taken. If you were to see here, the graph paper has been divided into so many discrete squares. It has been divided into squares. So these are the bigger squares, and in that square also you will find smaller squares are also present there. I know, right? Okay. So how do we take the scale? Scale is basically I'm referring about the length of the axis and the y-axis. Okay. So suppose the value is like this. For example, like this. A vehicle covers, let's say, 4 kilometer. A vehicle is covering 4 kilometer distance in, let's say, 2 minutes. Let's suppose right now, although it's not. Anyways, a vehicle is covering 4 kilometer distance in 2 minutes. So I need to plot it using this graph. So on the y-axis, I will start making divisions from, for example, here I've started making division from 1, 2, 3, 4, 5, because the values which you are having of distance is not very big. Getting it what I'm trying to say here? So according
Yes,
to
sir.
the question, you will be marking the numbers here, right? It will be like this: 1, then 2, then 3, then 4. So the numbers that you'll be marking on the x-axis and the y-axis, it has to be according to the values provided in the question. Suppose if the values were like this, 40 kilometer. So if I were to start taking from 1, 2, 3, 4, so the y-axis will be very long now. Huh? In fact, the value, the paper sheet, okay, the paper sheet, the graph paper sheet, the value 40 will not fit in it. It might not fit. If you were to
So,
take the
but then we
bigger
can.
squares, mhm.
So, but then we can use like I mean, we
Hmm.
can take 10 as our unit, right?
Exactly. We can take the smaller squares also in that case. Okay now. Right now, but reading the smaller square becomes quite difficult. Getting it? So if you were to take the values like this, for example, if I were to start counting from here, like 1, 2, 3, 4, 5. So where is 40? So 40 is to be found nowhere now. Okay. Like from here, you have to leave the 0. 1, 2, 3, 4. So rather than doing that, if you were to take the values like this, guys, here, if I were to take 10, getting it, 10, 20, 30, and then 40. So then it will be more convenient to take the scale as 10 now. 1 square equals to 10. This 1 square equals to 10. Yes. Are you guys able to connect or not?
Yes, sir.
Yes, sir.
Okay, Sundus, things.
I don't know.
Okay, shall I repeat this? Look here. If the paper is like this, let me draw it further like this. Now suppose the paper, the graph paper has been extended further. Now if I were to take if the question says that the value is 40 kilometer and we need to represent it on the y-axis, on this axis it has to be represented, right? Okay, I can represent the numbers like 1, 2, 3 and 4 very easily. For 1 square, this 1 square is representing 1 here. The second square represents 2, third square represents 3. But the value is 40, it's a bigger value now. So where will you be able to will you be able to represent the value 40 on this graph paper if you were to consider 1 square equals to 1? Huh? The answer is no now. Yes. Guys, are you there or not? Are you able to connect or not?
Yes, sir,
So,
we are.
so what we did now,
Yes, sir.
instead of taking 1 square equals to 1 unit, what we did, we consider 1 square equals to 10 unit. 10 unit is what now? 10 unit is nothing, but I'm talking about kilometer here, right now? Or it could be hour also if you were talking about the x-axis. Anyways, so in that
Okay,
case,
got
1
it. I
square will
got
be
it
taken.
now.
Got it now? So then in that case, I will be taking it as 10 kilometer, then 20, then 30, then 40. Getting it? So the scale to be taken has to be appropriate. So the two things have been done here. Now in the third thing, mark the values of time and distance in the graph, right? So we have done the marking as 1, 2, 3, 4 minutes here, 1, 2, 3, 4, 5, and so on kilometers here. Getting it? Okay now. Also,
Yes.
now in the question, it will be given that the vehicle, the question would be like this. The table would, you can plot a table, you can make a table from the values given in the question. In the question, it would be given like this: distance and time. The question will be saying that in 1 minute, 1 kilometer distance is being traveled. So what you will do, you will draw the vertical lines, perpendicular lines to the axis. You will draw a perpendicular line to the axis x at 1. Getting it now? Okay. And the question says that in 1 minute, 1 kilometer distance has been traveled. So you will also draw a perpendicular line on the y-axis at 1. So the point where they will be meeting, it will be representing what? It will be representing the speed of that body when at time 1 minute. Am I able to make you guys understand? Is it clear?
Sir, can you repeat this one more time?
Yeah, sure. What we are basically trying to find out here by plotting the graph between distance and time, we are basically finding the speed of the body at that particular moment, at that particular time. Huh? So it says that in 1 minute, the distance traveled by the body was 1 kilometer. So here is 1 minute now. Just Vaiga.
Yes,
Okay.
sir.
So you will draw a perpendicular line. What is perpendicular? You guys know, no?
Yes,
Line
sir.
at 190 degree. So you draw it here, and since it says that 1 kilometer distance has been traveled, so on the y-axis also you will be drawing a perpendicular axis like this, and the point where the two are meeting, that will show the speed of that body at that particular instance, right?
Okay, sir.
So here
Now
it
got it.
will be 1 kilometer per minute. 1 kilometer has
Okay.
been being traveled per minute. Again, now, Chakrika, what would be the speed of the body while at minute 2 minute?
Uh, 2 minutes. So we have to
Mhm.
find the speed.
Yeah, we're trying to find the speed, or just tell me that at 2 minutes, how much distance was being traveled by the body?
So 2
2
2
kilometer.
kilometer.
2 kilometer.
Yes, sir.
And Sundus, you tell me, if the distance of the body, distance traveled by the body was 2 kilometer in 2 minutes, then what would be the speed?
2 millimeters, sir.
Hmm?
What did you just say, sir?
I just say that the distance traveled by the body at 2 minutes was 2 kilometer. So at that point, what would be the speed of the body?
2 kilometer per 2 minutes.
Or it's better to say it like this: 2 kilometer upon 2 minutes. So two get cancelled, 1 kilometer per minute here. So here, even after 1 minute, there's a difference of 1 minute between 1 and 2 here now. So even after 1 minute, I'm seeing that the speed remains same now, 1 kilometer per minute. Okay. Now, in order to actually avoid the lengthy calculation, I haven't converted minute here into hour. Okay. Now, usually the standard way to write the speed is kilometer per hour or meter per second. But in order to avoid the lengthy calculation, we are just doing it in terms of minute only. Getting it now? Okay. Now,
Sir,
all
I didn't get it.
you didn't get it.
Yes.
I'm saying about the speed that Shakrika, if you see, and Vaiga, that kilometer per hour is usually the standard unit in which speed is written, or meter per
Yes, sir.
second, right now. But to
Yes.
avoid the calculation, lengthy calculation, I have just written it as 1 kilometer per minute. I haven't converted minute into hour here. Okay.
Okay,
So
sir.
how could it be 2 kilometers? It should be 2 kilometers per 2 minutes, right? Upon 2
Okay.
minutes.
Okay. Look here. 2 kilometer speed equals to distance upon time. 2 kilometer upon 2 minutes. 2 and 2 are getting cancelled here now. Yes. 2 and 2 gets cancelled here. So one is remaining here and one is remaining here also. So it's 1 kilometer per 1 minute now. Ask on this. Yeah. Is it
Oh, sir,
clear?
I got it. Yes.
Okay, that's what I've been saying. Okay, now at time 3 minutes, how much distance was travel, Vaiga?
So what, sir?
When the time was 3 minutes. Okay, then how much of distance was traveled? It was
3.
3 kilometer. Getting it now? So again, we
Yes.
will be plotting a graph and drawing the vertical lines. So then again, they are meeting here. Okay, now. So
Yes,
again,
sir.
if you were to try the speed here, speed is equal to distance upon time, d upon t, or it's 3 upon 3. That again gives you 1 kilometer per 1 minute. So you guys tell me, what are the things we have observed so far in this graph here? What have we observed? Which is constant? Which value is constant here? Which value is not changing?
So the speed.
The speed remains same. Hence, this graph which we have plotted is a graph of uniform motion.
Sir,
Yes.
I know it's not possible, but
Mhm.
then so if the distance is 4 kilometer
Mhm.
and it only took 2 minutes to cover,
Mhm.
can that be possible?
Look, if the distance is 4 kilometer and the speed and time taken is 2 minutes, you are saying that practically is it possible? That's what you are asking.
I know, sir, it's not practically possible, but then
Mhm.
I'm just asking.
Mhm. No, in that case, it won't be a case of uniform motion, because in that case, you will be getting the speed as 2 kilometer per minute right now. So here, had the speed been like this, okay,
So
at
is it
foot,
important to find it in the? Oh, okay. Yes, I get it now.
getting it now. So in that case, the so far you have been getting a speed as 1 kilometer, 1 kilometer per minute, 1 kilometer per minute, but now you're getting 2 kilometer per minute now. So in that case, obviously the speed is changing. Then it's not a case. It won't be a case of uniform motion any longer. All right. Okay. So that is the way how you are required to represent a graph, form a graph. Getting it now? Okay, is it clear to all three of you
Yes,
Yes,
sir.
sir.
Yes, sir.
right now? Okay, this is how you will be asked to draw the graph in exam. Okay, now
So
here's the
can you
thing.
just show it one more time? I
Yeah,
will
sure.
just do screenshot of it.
Yeah, sure. Take the screenshot. Yeah, done.
Yes, sir, done.
Mhm. Okay, then. Now moving on, they are different. Like in this type of graph, you were getting a straight line. Now you're getting a straight line. Okay, but apart from that, like if the nature of motion is different, if it's a non-uniform motion, huh? If it's a non-uniform motion, then you will be getting a curve shape. The graph would be like this. It will be looking like this. Okay, x-axis, y-axis, 0. This is your time. This is your distance. The graph might be like this, or the graph might be like this. So you won't be getting a straight line in the case of non-uniform motion. Getting it now? Okay, so remember the two things here. The two things are very important: a straight line shape of graph and the curve shape of graph. So interpretation is that straight line means the object is doing a uniform motion. Okay, it's moving with a fixed speed. Uniform motion means having a constant speed, like you had here 1 kilometer per minute, 1 kilometer per minute. The speed was constant there. Getting it now? While in the curved shape, the object has a non-uniform motion, right? And in that case, you see the object's speed might be increasing or might be decreasing. Yes. Okay. Okay. Let's do one thing. Let's plot a graph for non-uniform motion also with an example. Right now, guys. Okay. Then it will become more clear. Okay. By the way, Sundus, do explain to me what do you understand by non-uniform motion, by the way? Yes.
It will not have a straight line,
Mm-hmm.
and it is not in fixed speed.
Mm-hmm. Okay. It will not have a constant speed, and it won't be covering regular or fixed distance in regular interval of time, right? Okay. So let me get a blank page here.
Sir, I have a doubt.
Yes.
So I think maybe you're aware of races, right? Like Formula One.
Formula One cars. Yes,
Yes,
I'm
sir.
aware of. Yes, I'm aware of that.
Um, Not like that. Then there are cars
Mm-hmm.
which can go at a which can travel at a high speed in a very less time.
Mm-hmm.
So basically, like, isn't that a uniform motion?
They are uniform
Because
motion. Look here. The
I
thing
mean,
is now,
non-uniform motion. So I
it's
mean,
a case of
won't there be
non.
the no?
Exactly, that's a case of non-uniform motion because the Formula One racing cars, you see the pathway on which the track on which they are doing the race. Basically, the pathway is somewhat like this, right now. So with each turn, their speed will be changing. It will be slowed down a little bit. Getting it now? Okay.
Yes, sir, but
So
then
that's why.
this
Mhm.
and like the speed will already be denoted, right? Like they say this
Hmm.
much horsepower for in this much time, right? So
Usually the thing is now, the speed with which the driver is required to take turns for each turn, it has been like already prescribed. Okay, but the thing is now that the tracks are not at very equal distance. These turns are not at equal distance from each other. Somewhere it could be like 1 kilometer. Somewhere it could be only, for example, here it could be more than that. For example, it could be 2 kilometer for just for an example. Getting it now? So not equal distance are being traveled here. Now the speed here might be x here. The speed here might not be. The turn, the speed at which the turn was being taken here, it might be y. Getting it? Although the speed and time at which the driver is required to take the turns is it's almost prescribed. It's almost fixed. Okay. But then the thing is that the speed here and the speed here is different. It's y kilometer per hour. Here it's x kilometer per hour. Are you getting it? Yes.
Yes, sir.
So can you just like explain one more thing?
Okay, sure.
So
I'm
what
saying
is horse speed?
which is
Like horsepower. I mean horsepower.
yeah, horsepower. Okay, okay. Horsepower is it's a simply like it's a unit to measure the power of an engine. Okay, now horsepower,
Okay.
it is a unit to measure the power of engine. Okay, and by the way, 1 horsepower, or in short, it is written as 1 HP. It is equal to 745.7 watt. Okay, that is simply a horsepower. Okay,
Okay, okay, sir.
all right now. Also, like if you were to talk about horsepower in mechanical terms, okay, so in mechanical term, it means that like if the horse is able like to lift a weight of 250 kilogram, okay, above the ground by just 1 foot for 1 second. Okay, so in that terms also horsepower has been calculated. Like if the horse is able to lift a weight of 250 kilogram above the ground, how much? Above 1 feet, okay, for 1 second.
So what is horsepower?
Yeah, that's what I'm explaining here, that horsepower is simply the unit to measure the power of an engine. Okay, so it is calculated like the
It's a
it is
car.
calculated now of a engine of a car. Exactly, it could be engine of a car, it could be engine of tractors as well. Okay, so like it's calculated through the power needed to move 250 kilogram of weight. Like how much power you or me would require to move 250 kilogram of weight just 1 foot above the ground for just 1 second. Huh? How much power would be required to lift a weight of 250 kilogram or 1 foot above the ground for just 1 second? Getting it? What I'm trying to say?
Yes, sir.
Okay, so that is simply horsepower. Okay, anyways, coming back to our discussion, we're talking about non-uniform motion. So non-uniform motion will give you a graph somewhat like this. Okay, it could be like this, it could be like this, or it could be like this as well. Getting it now? Okay, so for let's take an example, then we will be able to understand it more clearly. So for example, time here is 1, 2, 3, 4. This is time in minutes. Okay, and then we are plotting the distance. Remember the axis on which value is represented on which axis. Simply in many times the question will be simply like this: distance is plotted on x-axis or y-axis. Your answer would be
Why?
y-axis, obviously, right? Now, so suppose the distance are being traveled like this.
Sir, can you ask the question again? I actually didn't get it.
Okay, my question is that if examiner asks you that distance is plotted on which axis of the graph, your answer would be y-axis, obviously,
Y-axis. Oh, okay, sir.
right? Now,
Yes,
okay,
yes.
in the fill in the blanks types, these types of questions are asked, right? Okay, so here if you were to plot the graph here, suppose for 1 minute the distance traveled is, let's say, 10. Getting it for first minute. Then for the second minute, let's say the distance traveled is, let's say, 15. This is a 15. Okay, now It's like this. Then for third minute, let's say the distance travel in the third minute by the body, let's say it is 40 now. Getting it now? Then again at the fourth minute, the distance traveled by the body, let's say it was now how much? 50. Getting it now? 50. Now
So
if
can it
you
be reduced by the fourth minute?
can it be reduced to?
Like, can it be decreased than
Hmm.
40 in the fourth minute?
It can be decreased also. Okay now. It can decrease, it can increase, because since we are talking about non-uniform motion. So if guys, if you were to connect the dots here, let's connect the dots here. Okay. Okay, what do you think? Is this graph giving you a straight line?
No,
No,
sir,
sir.
it's not uniform motion.
Exactly. So that is how non-uniform motion, the graph of a non-uniform motion will look like. Non-uniform motion. So if the question comes, then you guys can easily plot it. Okay. Okay. I'm right now giving one more question. Once you are done, you can send it on the WhatsApp. Okay now, from where you get the link of the class. Okay. So just on a, if you don't have the graph paper, on just a A4 size paper, on just a rough sheet of paper, you have to plot the graph of a uniform motion. Is it okay?
Yes, sir.
Okay. Also, if you guys were to observe one more thing, that at each point the speed is not same. Here it is 10 kilometer per minute. Right now, at this point it would be 15 upon 2, that is 7.5 kilometer per minute. While here the distance is 40 upon 3, that is 13.3 kilometer per minute. And here again the speed is how much? 50 upon 4, that is 12.25 kilometer per minute. So is the speed constant? Is the speed constant? 10 kilometer per
No,
minute,
sir.
then 7.5 kilometer per minute, then 13.3, and then we see 12.25. So speed does not remains constant in non-uniform motion. So first thing is that you get a curved line rather than a straight line. The second thing is speed changes. Okay, now question here is that I'm giving you the table. You simply have to plot the graph. No need to find the speed.
Sir, should we write down the table as well?
Yeah, write down the table as well. Distance is in kilometer. Okay now. Okay, it's supposed to be time, not a speed. And this is in minute. Okay. All right. 5.
So like we have
Okay.
to tell which like it is non-uniform or uniform motion.
Okay. First, you have to plot the graph. Then the answer will come whether it's a uniform motion or not uniform motion. Okay now.
Yes.
Sir,
Mm-hmm.
so should we also find the speed?
No, you can leave that. Okay now.
Okay, sir.
Okay, because drawing the graph might take some time. Also, guys, no need to take help of a scale, or like just you can draw it in a rough manner, but it should look neat and clean. Okay now.
So
Okay.
we
Because if you were to use the,
we
if you
should
were
draw
to,
the
Mhm.
graph.
you have to draw the graph. If you have the graph paper, then it's better to draw using the graph paper, or you can draw it on a plain sheet of paper as well. Once again, let me revise the points you need to take care of while you are plotting the graph. First thing is that plot the x and y axis carefully. The values on the x and y axis has to be plotted carefully. Then take the appropriate scale. Third thing is meet the lines. Okay, now perpendicular lines has to be meted. Then fourth, connect the dots. Okay.
Done, sir.
Done. Good. Do one thing, send that on the WhatsApp number, on the WhatsApp number from where you get your class links.
Okay, sir. Right now.
Yeah, right now.
Okay, sir.
Sir, if we don't have the graph paper, can we draw how you do it?
Yeah, you can draw it in the manner in which I drew. Okay.
Yes, sir.
Sir, what do you say?
I was saying that if you don't have graph paper, you can draw it in the manner in which I drew here. Okay now. Yes, Sundus, where are you? Are you in the class or not?
So I'm in the class. I'm just starting it.
Okay, okay.
See, 1 minute. Can I just go and come? Just for
Okay.
1 minute.
Okay, Sundus, no problem. Vaika, you have sent, no? Or Chakrika sent? I guess someone has sent.
1 second, sir. I'm taking the photo, sir.
Okay.
So, like, should we write in order like 5, 15, 25, 35, like that?
Yes, you have to write it in order. Okay, because it has been written here in order as well. Okay now.
Okay, so like we have to do it on the same like how you did, sir, right?
Exactly.
Okay,
Okay
sir.
now. Hmm. Actually, today I had some connection issues with my computer. That's why I was unable to join from the computer, and that's why you guys are not able to see me today. Okay now. Anyone who has sent the answers?
Sir, actually, I did it, but then I realized that actually the phones are with my dad, and my dad has the numbers, so I can't send it to you basically.
Okay. Okay, no problem. After the class, make sure you send that. Okay now.
Okay, sir. Shall I show it to you, sir?
Yes.
Should I show it to you?
If you show it in the class, yeah, okay, you can show it. Like, just give me a moment. I will have to stop sharing the screen then. Okay, you can show it. Okay, let me see that. Yeah, Chakrika. Okay, 1 is corresponding to 5, then yes, very good. Yes, Chakrika, that is good. Yes, Vaiga, have you sent it?
Sir, can you give me like 2 minutes?
Okay, sure. Take 2 more minutes. Meanwhile, Chakrika, you think of this shape of graph. When the shape of the graph will be parallel to the time axis. I mean this. In which case, the graph would be like this. Hmm? This is the slope. This is the graph here. This is the slope here. In which case, the slope will be parallel to the time axis. You think of this. Okay, while Vaiga is sending the answer, you think of this. Getting it now?
Okay.
Okay.
So I'm still having a doubt, like we have to write the
Hmm.
distances in a jumbled way or in an order, like
You have to write it in the orderly manner. Look here. First, what you will be doing, you will be taking the proper scale like this. Look here. You will be taking a proper scale starting from where? You might start from 10. Okay, you might start from 5. So let's say you start from 5, then you will be 10, okay, 15, 20, 25, 30, 35. In this manner, I am saying, okay. And here
okay, sir.
it will be 1, 2, 3, 4, and 5, right?
So like, but
Mhm.
you draw it in a jumbled way, right? So like, how will we connect that?
Yes, you can connect it now. Look here. For example, for 1 minute, the distance traveled is here. For second minute, the distance traveled is 15 here. Yeah. For the minute, for the time 3 minutes, the distance traveled is 35. So we can
So like,
connect it. Mhm.
but like, sir, see, like for 3, you
Mhm.
gave it like 35, and for 5, you gave it 25. So like,
Yeah. So in that case, what will happen? You will have to come back to 25 then to this. The graph will go upwards first. The graph will look like this from here to here to there. right now. Then after 50, you will come back to the distance 25. Like suppose the graph is going here, but then again suddenly you will come back here. Getting in what I'm saying?
Oh yes, yeah, yes, sir.
Okay. Okay. Meanwhile, Chakrika, you think of this. In which
Sir,
case,
I have to get the time or distance, sir.
yeah, this is a graph between distance and time here. Okay. You actually have to say, like, for the graph in which you are getting a straight line, you say that it's a graph for uniform motion. For the graph in which you were getting a curved shape, you say that it's a non-uniform motion. What if the graph is like this, in which you are getting a line which is parallel to the time? You know what is
Oh,
parallel? When two lines do
yes, sir.
not
Yes, sir.
intersect each other. So
They never
that
meet
will
each other.
happen in which case?
Okay, sir. Just a second.
Hmm. Yeah, is Sundar's back in the class or not?
Yes, I'm back, sir.
Yeah. Okay.
So like, can you just show it
Mhm.
me? Like, I'm not getting it.
Okay. Look here. You will be joining the lines. I guess you have done that already,
Yes, sir.
right now. The points are like this. And suppose, okay, let me erase this thing here. Right. Okay, suppose you wait, draw it further like this. With 35, then 40, 45, and then 50 here. It's not a straight line, by the way. Anyways, now if you were to plot the graph for 4 minutes and 50 here, right? So it will be looking like this now. Right? This point you are getting here.
Yes, sir. So if it was
Hmm.
like 4 and 15, like,
Hmm. If it was for 5 and 25, right? So it would be like this then.
yes, sir, so it's okay.
It's okay. Look here. You will be drawing it like this, then you will be drawing it like this now. Getting it now? So you have
Yes.
been traveling like this all the way upward. Now you're coming backward to the downward
Okay,
side.
sir. I
That's
had
how
a
the
doubt
graph
on
will be
that.
plotted. Okay, that's how
Okay.
Chakrika did it. Okay, Sundus, what about you?
Ma'am, just I mean, sir, sorry, just wait. Can you just wait for 2 minutes?
Okay, okay. Hmm. Also, Chakrika, have you been able to think of it like when, in which case it will be parallel to the time?
Sir, the only thing I got is that when
Hmm.
if the slope is parallel to the time, the distance and the time, like I mean, we can't find the speed of them.
Look here.
So like,
Suppose, Mhm.
how do we?
Okay, suppose nothing is that you have traveled, let's say, 5 kilometer. Okay, and your car is now, let's say, unfortunately, is out of fuel now. It's not moving any further. So the time keeps increasing now. 1 hour, 2 hour, 3 hour, right? The time is increasing, but you are not moving any further now. You have traveled only 5 kilometer. Thereafter, you cannot travel any further because what? Because your fuel has run out. Getting it now? So
Yes.
for 1 hour, 1 hour elapsed. 1 hour has passed. You are still at 5 kilometer. You have still at the distance of 5 kilometer. 2 hour has passed. You are still at the same destination, same point. 3 hours has passed. You're still standing at the same point. Getting it? What I'm trying to say here?
So we're at rest.
Yes.
So we're basically at rest.
Exactly. The body is at rest here. The
Sir,
body is not moving. Mhm.
is it compulsory to draw the line?
To draw the
Line,
okay,
the
you can
line.
just add the points. Okay.
Sir,
Look.
I
Sir,
tried it,
Mhm.
sir. I sent it.
it is getting
Hmm.
it is getting very fast. I mean, it is like
You
25
have
is
to
very fast.
actually you have to take the proper graph here. Okay. Why you have sent this?